In section 24, we're going to learn the properties of exponents. So we're going to know and apply. There's 6 rules to exponents, and then we're going to apply multiple rules of exponents to a single expression. So we'll come back to our entrance slip later on after we go through the rules. But these are just the basic problems that we're going to go through. So these 6 problems. So for our notes. So for all expressions involving exponents, there's 2 parts. So there's the base and then the exponent. So in the expression 2 cubed, we have 2, that's the base, and then 3, that's the exponent. So go ahead and identify based on 2 cubed, the base and the exponent for each expression below. So numbers 1 through 4. So hopefully you pause the video and you have these as the answer. So in number 1, my base is 8, the exponent's 5. In number 2, my base is x, the exponent's 4. In number 3, my base is 3, the exponent's 2. And then in number 4, the base is 7 and the exponent is x. Now the base is really important as we go through the rest of these problems because for most of the problems, if the bases are not the same, you can't apply any of the rules to the exponents. The one thing that does not matter what kind of base you have is when anything is raised to the exponent of 0. Any quantity raised to the exponent of 0 will always be equal to 1. So the number 1. So in number 5, we have 7 to the power of 0. That answers 1. In number 6, we have negative 2 raised to the power of 0, and that answers also 1. For number 7, we have 4 raised to the power of 0, again, 1. For number 8, 1 to the power of 0 is 1. And then number 9, negative 2 raised to the power of 0 is 1. Now, in number 9, because there's this negative side out in front, you also have to apply that negative sign into this problem. So it's actually negative 1 because what it's doing is taking 2 to the power of 0, which is 1, and then we're applying that negative sign. So the answer is actually negative 1. That's our first rule. The next rule is when we have negative exponents. A negative exponent indicates that you need to take the reciprocal of the expression. So let's go ahead and write that word, the reciprocal. Now, whenever we take the reciprocal of an expression, we are actually flipping it. So in the first 3 problems, 10, 11, and 12, you'll see that all of the bases are in the quote-unquote numerator, whereas in numbers 13 through 15, all of the bases with a negative exponent are in the denominator. So in number 10, you're going to go ahead and take x to the negative 4, and we're going to bring it to the denominator, so it's 1 over x to the power of positive 4. So by taking the reciprocal of the expression, the exponent now becomes positive. In number 11, we have 3 to the power of negative 2, so we can write this as 1 over 3 squared, which we can also say is 1 over 9. In number 12, we have a to the 5th, a to the negative 5th. So we're going to put 1 over, we have a to the negative 5th, turns into a to the 5th. So we take the reciprocal. Numbers 13 through 15, the base is each a variable raised to a negative exponent, and you're going to move it into the numerator. So we're going to take the reciprocal by moving it to the numerator. That is flipping it. So we have 1y cubed, or you could just say y cubed. In number 14, we're going to move this to the numerator, so we have 3x to the 4th. In number 15, we're just going to take c to the negative 5th, and we're going to move it to the numerator, so we have 7bc to the 5th. So anytime we have a negative exponent, we are moving it. And it just applies to that one single base. So in number 15, I'm not moving 7, and I'm not moving b because 7 has an exponent of positive 1, and b also has an exponent of positive 1. So we keep those in the numerator position. We are just moving that denominator. Numbers 16 through 18, each of these has that multiplication symbol in between. So we are multiplying, multiplying, and multiplying. So anytime the operation is to multiply, and they have to have the same base, you're going to add the exponents. So we're going to have, in number 16, then my base is 2. So we're going to do 2 plus 3. So we are adding the exponents. So we have 2 to the power of 5. In number 17, you are adding the exponents. So we have 3, and then we have 4 plus 2. So we have 3 to the power of 6. In number 18, my base is 7. So we're going to add these exponents. We have 3 plus 5, so we have 7 to the power of 8. My fourth rule is when dividing expressions with the same base, we're going to do the opposite. So multiplying, we add. Dividing, we actually subtract the expression. So for number 19, my base is 3. We're going to do 5 minus 2. So we have 3 to the power of 3. And you can leave it just like this. You don't have to write down 27. In number 20, we have 4 to the 10th divided by 4 to the 4th. So we have base of 4, so we're going to do 10 minus 4. So we have 4 to the power of 6. Number 21, we have 2 to the power of 3 minus 5. So in this problem, we have 2 to the power of negative 2. But remember, you can't have a negative exponent, so we're going to move it to the denominator. We're going to take the reciprocal of it so that the exponent is now positive. In number 22, we have the base of 5, and we have 3 minus 7. So we have 5 to the power of negative 4. So we're going to put 1 over 5 to the 4th. So we took the reciprocal, and that's my final answer. So when dividing expressions with the same base, we subtract the exponents. Now, given the product of expressions raised to an exponent, you are going to distribute. Which means that you're going to be multiplying the exponents. So we're multiplying the exponents. So for number 23, 24, 25, and 26, we have 2 and 3 inside of the parentheses. We have 5 and 4 inside the parentheses, 7 and 6 inside the parentheses, and then we have 1, 3, 1, and 2 inside of the parentheses. So we're going to distribute the exponent into the exponent spot for each of the numbers inside of the parentheses. So we have 2 to the 4th, 3 to the 4th, then we have 5 cubed, 4 cubed, then we have 7 to the 5th, and 6 to the 5th. And then we're going to take the 3 and distribute it to all of the numbers. So we have 1 cubed divided by 3 cubed times 1 cubed divided by 2 cubed. And please leave it just like this. You'll see as we get into the next lessons, 25 and 26, there's a reason why we're doing it like this, and that's because, especially when you do your practice set, the number in the numerator is not always 1. So I want to make sure that you are distributing that 3 to all 4 of the numbers inside of the parentheses, including that 1. Now, distribute means that we're multiplying. So when we have an exponent raised to an exponent, you're going to, once again, distribute, which means that we're going to be multiplying. So we have 2, and then we multiply these 2. 2 times 3 is 6. In number 28, we're going to multiply these 2. So we have 3 to the power of 8. Number 29, we're going to multiply these 2. So we have 9 to the power of 6. And then in number 30, we multiply these 2. So we have 1/3 to the power of 10. And then we can distribute the 10 to the 1 and the 3. So we have 1 to the 10th divided by 3 to the 10th. So before we go on to numbers 31 to 36, let's go ahead and go back up to our entrance slip. Go ahead and pause the video and complete numbers 1 through 6. So for number 1, we are subtracting, so we have x cubed. Number 2, we're adding the exponents, we have x to the 11th. In number 3, we have x to the 4th raised to the power of 0. Anything raised to the power of 0 is always going to be 1. In number 4, we're going to multiply the exponents using distribution, so we have x to the 6th. In number 5, you're doing 2 things. First, you're adding the exponents, and then because you have a negative exponent, you need to take the reciprocal of it. And then in number 6, we distribute the 5 to the x and the y. So it goes to both terms. Well, it's one term, but it goes to both items inside of the parentheses. So moving on to numbers 31 to 36, these are a little bit more complicated. Anytime that you have a number, all right, you're actually multiplying those. So for number 31, you're actually multiplying -2 times -2. So we have -2 times -2, which is +4. And then we have x squared times x, which means that we are adding the exponents. So we have x to the power of 3, and that's my final answer. For number 31, I need you to make sure that you have a 1 in front of that negative sign, all right? So for this first one, we're distributing the 4 to the -1, c squared, and d. So we have -1 to the 4th, c to the 8th, and then d to the 4th. And then we have times, we have -1 c squared d to the 4th. So we have -1 to the 4th, which is a positive 1. So we have positive 1 times -1, which actually ends up being -1. Then we have c. So we have 8 plus 2, which is 10. So we have c to the 10th. And then we have d. So we have 4 plus 4, which is 8. So we have d to the 8th. In number 33, I'm going to drop down that -4 because we don't have anything else to multiply by. So we have -4. I'm going to combine a and a. So we have a squared, because 1 plus 1 is 2. And then b to the 1, 1 plus 3 is 4. So we have b to the 4th. In number 34, you're going to start by noticing that we have x squared y all raised to the power of 0, which means that this entire thing is just the number 1 divided by. And then you can go ahead and distribute the -3 to the x and the y cubed. So we have x cubed y to the -9th. So we have x to the negative cubed, y to the -9th. Both of them need to be moved to the numerator. Take the reciprocal. My final answer is x cubed, y to the 9th. In number 35, you are going to be dividing 35 divided by -5. So those are just numbers, so we can't forget our division skills. So that's just -7. And then when we divide x cubed divided by x to the 5th, we're subtracting the exponents. So we have x to the power of 3 minus 5. And then we have y to the 8th divided by y to the 1. So we have y to the power of 8 minus 1. So it's subtraction. So we have -7, x to the -2, y to the 7th. Now the only thing that we have to bring into the denominator, take the reciprocal of, is x to the -2 because the exponent's negative. So we have in the numerator -7 and y to the 7th divided by x squared. And then finally, number 36. So we're going to start by multiplying. So we have x to the power of -6 times x squared. So we have x, so between these two we have to add them. So we have -6 plus 2. So we have x to the power of -4. Take the reciprocal, so we have 1 over x to the 4th. So we are applying multiple rules in this one. Go ahead and try the exit slip and pause the screen. Go ahead and check your answers when you're ready. So you need to remember the 6 rules, and you can go ahead and apply these rules to the rest of the sections that we're going to learn in this unit.